Right now, at this exact moment, October 29th, 2025, at 11:47 Universal Time, something unprecedented is happening 203 million kilometers from Earth. The interstellar object 3I, Atlas, is reaching perihelion, its closest approach to our Sun, and what should be the most watched moment in modern astronomy is shrouded in deafening silence. NASA's tracking systems have gone mysteriously quiet. Telescopes that should be streaming real-time data are reporting technical difficulties. Observatories around the world have simultaneously lost connection to their networks. And most disturbing of all, this information blackout is happening precisely when the object is hidden behind the Sun, in the perfect blind spot where, if it were artificial, it could execute the most efficient maneuver possible without any terrestrial witness. Harvard astrophysicist Avi Loeb made a statement that chilled the scientific community to the bone. Take vacations before October 29th. When pressed about what he meant, he just smiled and said that some dates are more important than others in human history. Leaked documents suggest emergency meetings at the Pentagon. Planetary defense protocols activated without public announcement. And now, as I speak these words, 3I, Atlas, is doing something at the deepest point of our solar system's gravity well, and we can't see it. It all began on a seemingly ordinary night, July 1st, 2025. Astronomers at the Atlas telescope in Chile were conducting their routine sky survey when they detected something that immediately triggered every alarm. The initial data didn't make sense. The speed was impossible. The trajectory defied probability. Within hours, observatories around the world were converging their instruments on the same point in the sky, and confirmation came like a punch to the gut. We had our third confirmed interstellar visitor. But 3I Atlas wasn't like Oumuamua in 2017 or Comet Borisov in 2019. This was different, terrifyingly different. Racing through our solar system at 245,000 kilometers per hour, 68 kilometers per second, it instantly became the fastest object ever observed within our cosmic neighborhood. To put that in perspective, it's fast enough to travel from Earth to the Moon in under 2 hours. Size estimates sent shockwaves through NASA's corridors. Minimum diameter of 5 kilometers, the size of a small city. Mass of 33 billion tons. That's 1,000 times more massive than our previous visitors combined. An anonymous JPL official described it as, not a space rock, it's a space mountain traveling at speeds we can barely comprehend. But the real alarm came from trajectory analysis. The object was aligned almost perfectly with our solar system's ecliptic plane, the flat disk where all planets orbit. The inclination, just 5 degrees. The odds of this happening naturally with an object from interstellar space? Less than 2%. As one scientist put it in a leaked email, it's like someone throwing a dart from another star system and hitting not just our target, but the exact center of the target. When spectrographs began analyzing 3I Atlas's composition, scientists expected to find typical comet chemistry, water ice, maybe some organic compounds, standard cosmic dust. What they found instead shook the foundations of astrochemistry. The Very Large Telescope in Chile was first to detect the anomaly. Nickel vapor in the object's coma, the bright clouds surrounding it. That alone was unusual, but not impossible. But then came the result that made scientists check and recheck their instruments. No iron, zero, none. In cosmic chemistry, nickel and iron are inseparable companions. They form together in stellar furnaces, travel together through space, exist in predictable ratios in every natural object ever studied. Finding nickel without iron is like finding smoke without fire, waves without water. It simply doesn't happen. Unless the nickel has been processed, refined, separated by artificial means. The situation got even stranger. Later analyses detected nickel tetracarbonyl, a compound that on Earth only exists in industrial processes. It's used in refineries, in the production of high-precision electronics. Finding it floating through interstellar space? Scientists don't even have models to explain how it could form naturally. The carbon dioxide to water ratio measured an astonishing 8:1. the highest ever recorded in any cosmic object. For reference, most comets have ratios close to 1:1. What could create such a concentration of CO2? What kind of environment? What kind of processes? Then came the image that changed everything. On July 21st, the Hubble Space Telescope captured 3I, Atlas, in unprecedented detail. But instead of the typical comet tail pointing away from the Sun, there was a forward-pointing jet directly toward the Sunday. This defies basic comet physics. Solar radiation pressure always pushes material away, never toward, unless that jet isn't material being pushed, but something being propelled. In September, a coronal mass ejection, a massive blast of solar plasma, hit 3I Atlas directly. Scientists prepared to watch the object shatter like cosmic glass. Comets are fragile, held together by weak gravitational forces and dirty ice. A direct hit from a CME should have obliterated it. Instead, it emerged unscathed, maintaining perfect rotational stability that a classified report described as incompatible with a natural aggregate of ice and dust. Today's perihelion isn't just a celestial milestone, it's an opportunity window calculated with surgical precision. At this exact moment, 3I, Atlas, sits at the deepest point in our Sun's gravity well. This is where the Oberth effect, named after pioneering physicist Hermann Oberth, makes any propulsive maneuver exponentially more efficient. Think of it like a skateboarder going down a ramp. At the lowest point, where speed is maximum, any additional push produces the maximum energy gain. For a spacecraft, burning fuel at perihelion can achieve velocity changes that would be impossible at any other point in the orbit. A small impulse now, perhaps just a few hundred meters per second, could completely transform 3I Atlas's trajectory. It could convert its hyperbolic escape trajectory into a closed elliptical orbit, permanently capturing itself in our solar system. It could redirect it towards specific encounters with inner planets. It could allow it to release smaller probes that, leveraging the mothership's velocity and the Sun's gravitational boost, would reach their targets with otherwise impossible efficiency. The timing is mathematically perfect, too perfect. Harvard's team calculated the odds. This precise alignment, this exact geometry, occurs in less than 0.01% of truly random approaches. It's like winning the cosmic lottery, if the lottery was rigged. And here's the most chilling detail. The object's approach vector traces back to within 9 degrees of where we received the famous "wow" signal in 1977, that 72-second pulse of unknown origin that has never been explained. Loeb's team gives 3I, Atlas, a 40% probability of artificial origin. His words haunt the scientific community. A sufficiently advanced civilization would choose exactly this trajectory, exactly this timing. It's the perfect approach, maximum operational efficiency, minimum chance of detection. The pattern of institutional silence is deafening and revealing. When Mars orbiters made their flyby on October 3rd, they captured what sources describe as unprecedented resolution images of 3I Atlas passing just 29 million kilometers away. 2 weeks later, not a single photograph has been released, not one pixel. NASA initially cited the government shutdown, but the shutdown conveniently began on October 1st, 1 day before the flyby. Internal sources paint a different picture. Emergency meetings at JPL, classified sessions with Space Force, direct orders from the National Security Council to withhold all data pending additional security analysis. A leaked email mentions anomalies requiring confirmation before public release and implications exceeding standard scientific protocols. The International Asteroid Warning Network quietly added 3I Atlas to their threat assessment list on October 21st, interstellar object. Documents justify this as a precautionary measure due to trajectory uncertainties, but observers note the trajectory has been predicted to kilometer precision for months. Amateur astronomers detected mysterious radio pulses at 1,420 MHz, the hydrogen line frequency that SETI researchers call the cosmic water hole. It's the universal frequency for communication, the one any technological civilization would know. The pulses followed a pattern, not random, not natural. When questioned, NASA's response was terse: "We're studying unusual outgassing patterns." But outgassing doesn't produce modulated radio signals. Multiple sources confirm planetary defense systems were activated without public announcement. Resources normally reserved for extinction-level threats now track a comet that supposedly poses no danger. Why? What do they know that they're not telling us? As I speak these words, 3I Atlas is bathed in 770 watts per square meter of solar radiation. Across its minimum 78 square kilometer surface, that translates to over 33 gigawatts of total power. For perspective, that's equivalent to 1/3 of America's total nuclear power output. It's enough energy to power 25 million homes. For a natural comet, this inferno should trigger catastrophic disintegration. Ice turns to vapor so rapidly it creates explosive forces. Temperature gradients, one side baking at hundreds of degrees, the other frozen in vacuum, generate mechanical stress no fragile structure of dirty ice could withstand. We should be seeing a spectacular light show visible across the inner solar system. But what if it doesn't break apart? What if those ices, detected by spectrographs, aren't ice at all, but something designed to mimic spectral signatures? What if that hollow structure, suggested by density measurements, houses something waiting for exactly this moment? A precisely timed engine burn right now, just an impulse of perhaps 500 meters per second, could fundamentally alter its fate. The mathematics are relentless. Any artificial maneuver would be 400% more efficient at this exact moment than at any other point in its journey. It could transform its hyperbolic escape trajectory into a closed orbit, trapping itself within our solar system forever. Or worse, it could release a swarm of smaller probes. The orbital mechanics are clear. Objects released at perihelion with specific velocity vectors could reach any inner planet with otherwise impossible fuel efficiency. Mars in 3 months, Venus in 5, Earth in 7. Each too small to detect until it's too late. The real test begins when 3I Atlas emerges from behind the Sun in early November. Every major observatory has cleared their schedules. Telescope time that would normally be booked years in advance has been freed for high-priority observations of transient targets. The global astronomical community is collectively holding its breath. On November 4th, ESA's JUICE spacecraft will pass within 64 million kilometers, close enough for its instruments to detect structural changes, deployed objects, or anomalous emissions. JUICE's data will take weeks to fully transmit, but the first images should reveal whether 3I Atlas survived intact. The pattern of upcoming encounters reads like a strategic flight plan rather than cosmic coincidence. Venus on November 3rd at 97 million kilometers, close enough for detailed observations, far enough to avoid planetary defenses. Earth on December 19th at 267 million kilometers, beyond our moon but within high bandwidth communications range. And then the grand finale, Jupiter on March 16, 2026, where NASA's Juno probe waits with instruments capable of detecting even the faintest artificial transmissions. Each encounter represents a window for observation or infiltration. If smaller probes were released during perihelion, orbital mechanics dictate they'd reach Earth's vicinity by late January 2026. Enough time to decelerate, maneuver, perhaps even establish stable orbits before detection. Too small for our defense systems to track, arriving with our own sun's gravitational blessing. When our telescopes finally reacquire 3I Atlas, we'll face possibilities that will forever redefine our understanding of our place in the cosmos. Science deals with evidence, not speculation, but the evidence points to 3 distinct scenarios, each with profound implications. First, we might find it intact but altered, still following roughly its predicted path, but showing signs of the perihelion passage, perhaps increased outgassing, perhaps changes in rotation, perhaps that strange nickel chemistry finally making sense through some exotic natural process we don't yet understand. This would be the most comforting outcome: mystery solved, physics validated, peaceful sleep restored. Second, we could discover a debris field where 33 billion tons of matter once traveled. Fragments scattered across millions of kilometers, each piece following its own slightly divergent orbit. Spectroscopy would reveal common water ice, typical silicates, maybe some organics -6, but nothing more exotic than an extraordinarily large comet that couldn't take the heat. The scientific community would collectively sigh in relief. Another anomaly resolved by conventional physics. But it's the third possibility that keeps scientists awake, staring at equations that refuse to balance, data that defies explanation. What if we find nothing? What if those carefully calculated trajectory predictions, refined through thousands of observations over months, lead to emptiness? No debris, no fragments, no expanding dust cloud. Just the empty vastness of space where a mountain-sized object should be. Physics doesn't allow objects to disappear. Conservation of mass and energy are fundamental laws, not suggestions. Yet we've already watched 3I, Atlas defy expectations at every turn. Impossible chemistry, impossible structural stability, impossible trajectory alignment. How much more impossible would be too much? Consider the implications. We're dealing with an object that arrived with precision that defies chance, exhibited chemistry that shouldn't exist outside a factory, timed its closest solar approach to coincide perfectly with our observational blind spot. Either we're witnessing the most extraordinary series of coincidences in astronomical history, or we just watched something execute a maneuver we were never meant to see. The coming weeks will bring answers, but perhaps not the answers we want to hear. If 3I, Atlas reappears unchanged, we'll have dodged a cosmic bullet and learned the universe is even stranger than we imagined. If we find debris, we'll confirm that sometimes even space mountains follow the rules. But if we find nothing, if this interstellar visitor simply vanishes during its solar passage, then we'll have our answer about whether we're alone. And that answer will come not through radio signals or messages of peace, but through a demonstration of capabilities that make our greatest technological achievements look like children's toys. Remember, in history, the Trojan horse looked like a gift. It seemed benign. It seemed worthy of close study. Only too late did the Trojans discover that curiosity about mysterious visitors can carry existential consequences. November will bring clarity, December will bring confirmation, January might bring contact or conquest. Until then, watch the pre-dawn sky. Look for new lights where there should be none. Listen to frequencies that carry more than cosmic noise. And ask yourself, in a universe of infinite possibilities, what are the odds that the greatest event in human history begins not with fanfare, but with silence? 3I, Atlas has already taught us one lesson. Whether it's natural or not, the universe has no obligation to conform to our expectations. It doesn't warn us before changing everything. And sometimes, the most important moments in history happen not under humanity's watchful eyes, but in the darkness behind our own sun, where secrets can unfold without witnesses and fates can be sealed without our knowledge. The countdown has begun, not for perihelion that has already passed as you listen to my words. The countdown now is for truth, for discovery, for the answer to the question humanity has asked since we first looked at the stars: are we alone? Soon, one way or another, we'll know. And that knowledge, whether comforting or terrifying, will change everything, forever.